Okay. Now today we look at the beam structure again. So we are looking at the handouts. Tutorial question number 8. It is in your handouts. Question number 8. So this picture will tell you that you are having a beam structure that having a loss of boundary condition here, a beam structure and a spring there. So in this example, it's break into 3 elements. So element 1 will be have point 1 and point 2. Point 2 is a roller pin here. It's a roller. And then there is a round body here, a round support here. Element 2 will be connecting point 2 and point 3. Point 3 having a force here, 50 kilonewton. And the K is given for the spring, right? So this question is a combination of beam and spring. Yeah, beam and spring. For your info, your test will be either next week or another week. Yeah, so just prepare for it. It will be either next week Wednesday or the next Monday. All right, take note. Your test one will be either next week Wednesday or another week Monday. It will cover chapter 1, chapter 2, chapter 3. Okay. All right. And the dimensions given. Point 1 to point 2 is 3 meter. Point 2 to point 3 is 3 meter. You need to determine the nodal displacement or rotation, plus the global and element force for the beam. And the E is given, I is given, K is given. So let's start solving this question. We are focusing on beam here. All right. Now, if you pull the diagram to one side, and then you focus on what is needed for your answer. As usual, you start with the general equation. For beam, you call out the beam equation, beam matrix, K equal to EIL 3 and 4 times 4 matrix. The number here is standard already. So you look at element 1, you are having 1 and 2, meaning that this 2 column is 0.1, this 2 column is 0.2. Right, I put in the black mark here, which is the V1 rotation 1, V2 rotation 2, same with this over here. Yeah. So again, for your exam or for your test later on, all this black color notation, you use pencil. You use pencil. Don't use a pen to write, because it's not part of the matrix. It's just a signboard, or it's just a guide for you to put into the global matrix later on. So for element 2, same equation. However, the meaning inside all this number will be different. If we look at element 2 connecting 2 and 3. So this one is this one is 0.2, this one is 0.3. So we have vertical displacement 2, rotation 2, V3, and rotation 3. All right. Element 3 is just a spring. So spring, you only have this one. Yeah, you only have K for the standard matrix. Yeah? So element is F equal to KD, but the K for spring is this simple only, K minus K minus KK. Yeah? Then you combine everything into, you can modify it lah. So this one, if you write in equation later on, because your spring is in vertical orientation, so your force will be small force, because we're looking at element, small f, F3y, F4y, because it's connecting 0.3 and 0.4. All right, and V3 and V4 over here. So this question combine what we learned in chapter 2 or maybe chapter 1 in this question. Then after that, any question for these slides? Any question for the K element? Anything that you're not sure about the K? You can ask me now. No, no. Okay, later I have question for you. All right. After that, we combine everything in the K. So we put the marking first, because from this case we will have uh, 1, 2, 3, 4, 5, 6, 7, 7 times 7 matrix here. Why is not 8? Why is not 9? Yeah, because we only have we are combining the vertical displacement and rotation in this matrix. Although you look at element 3, there is yeah. So if you look at all the parameter in the element, so K you have V1 rotation 1, V2 rotation 2. Element 2 you have V2 rotation 2, V and rotation set for 0.3. And for spring you have vertical displacement 3 and 4. So if you count the unknown or free body, the free degree of freedoms. So you count 1, 2, 3, 4, 5. This one repeated just now. V2, 1, 2, 3, 4, 5, 6. V3 repeated, and V4. You have 7 degree of freedoms. So you have 1, 2, 3, 4, 5, 6, 7. Any question for the row and column for the matrix? Clear? Okay. The next one I will show you slowly the steps. So you start putting the element into the standard matrix, global standard matrix here. You put according to the parking lot. Yeah. So same with this over here. If you want to more clear, you just write something over here. You repeat the same. Then you know how to park. So the first one you put inside here. Yeah. So because the first element is rotation 1, vertical displacement rotation 1, and V2 rotation 2. So you put all the number in this 4 times 4 matrix here. Then you look at element 2. Element 2 is 0.2 and 0.3, so you focus on 0.2 and 0.3 will be somewhere here. Right, I highlight with the dash line here. And then element 3 will be V3 and V4. So be careful when you do something for element 3 put into a global scale. You're focusing on V3 and V4, yeah? So don't fill in the rotation column for element 3. So there will be something around here. Okay? Clear for this illustration? La, you understand?
Okay.
Okay, yeah? All right. Katana, you understand? All right. Singy, any question?
No question.
Okay, good. All right. After you combine, you get something like you see on the screen here, right? You get something on the screen here. So you should understand why I put a plus there. So in your coming test, you need to show me how you add up all the numbers here, right? So you write the matrix with all the plus, and then you write one more time the complete one. Yeah. All right. Again, in your answer later on, try not to use symmetry in your answer. You need to write the full matrix in your test. Yeah. So you just repeat over this section and you put in here. Okay. Yeah, repeat. for your test or final exam, you need to write a full matrix. Don't use symmetry. Yeah? Here is because you want to save time when you generate the PowerPoint slide for the lecture. Right. All right, so I highlight the green color again, just for your info. Then the second one, then the third one. So you can see that the third one, we're only interested in a V3 and V4 element, yeah? All right. So now you understand why suddenly here, because if you look at a K here, element 3, if you put inside there, you should have K. But why suddenly you have a L3 divided by EI? Now you understand?
No, really understand.
Okay. Katana, you understand why suddenly your elementary K, when you transport into the global matrix here, why there is a KL cube divided by EI? You understand?
Right.
No, do you understand?
Oh,
No. Singi, you understand why we write when we transport K for elementary, why suddenly we become KL cube divided by EI?
Because elementary is spring, so don't have the EI over L3 there, so we must divide it to cancel out.
Yes, correct. If you transfer K inside here, because your global matrix here, you have a constant value outside the bracket here. So you need to add some unknown, you need to add some constant value to the K, so that when you put EI divided by L cube, you times K over L3 EI, you'll be equal to K. Now you understand? Now I cannot hear you.
Yes, sir.
Katana, you get it now?
yes.
All right. So this kind of method you need to employ, or you need to be careful when it comes to test and exam. Yeah. So just let you know. Don't straight away write K inside the global matrix. You need to consider what is happening outside the matrix here. There is an unknown value here. Not unknown, but it's a constant value outside the matrix here. So you need to be careful when you import the K here. So that's why you will have over this side. So again, there is a number here because it's symmetry. So there's a number here. All right, Katana, what is the number here? Katana, are you there? This question is for you. Katana, are you there?
Yes, sir.
Okay, what is the answer for the question mark here? Lai, can you answer? What is the question mark answer for this one?
Negative KL cube over EI.
Okay, good, excellent. Katana, you understand?
Yes, the symmetry.
Yeah, even is symmetry, but do you know how to write this number? Why this number is negative K L cube EI? You understand? You know how to extract the information.
Yes.
You extract from this one,
Yes, sir.
okay. Then you convert. When you put inside global, be careful on the constant value there. All right, good, excellent. All right, then the next one, we just go ahead and solve with just now the slide here is the stiffness matrix. Then you put into F equal to KD. So again, what you have on the F component, if you analysis beam, you have force and moment on the left hand side, and then you have the displacement and rotation on the right hand side here for the D. All right, so and from here, you know that the K prime here, I just represent with the KL cube divided by EI. Right, this one, because it's quite a complicated fraction here when you try to put into the PowerPoint. All right, you have lots of adjustment need to do. So I just replace with K prime with this one. Yeah. Then you solve it. Yeah. So you solve for this one. So apply boundary condition. So my question is that what boundary condition that you can put here? Singy, what is the boundary condition for point number 1? What can you put over here?
The rotation. There's no rotation.
Okay. And then, so this is no rotation, 0. Then what else? Point 1, can it move?
No.
Okay, so this one also 0. All right. Lie. What about point number 2? What boundary condition that you can set for point 2? Lie, are you there? Yeah. So what boundary condition we can set for point number 2? If you look at here, which one is 0?
Force going down.
Again, the connection is not very good at your side. Can you repeat your answer? All right, the connection is breakout at your side. Okay, never mind. Katana, what is the boundary condition we can set for point 2?
0 displacement.
There's no displacement, yeah? So 0. This one is 0. So not, and then okay, then the rest, point 4 you know lah, point 4 also same. So V1 0, rotation 1 0. So after that, you can just close it, not cancel, but you close it. I close it with the line here. I close it, the column and row. The next one, rotation, no, vertical displacement 2 is 0. So I close the V2 row and column. So I start reducing the matrix already. Yeah? You need the same technique for your coming test. So V4 here, is 0, not able to move vertically, 0.4. So you close number 4. Then you close number 4. So as you can see here, you only left out 6 unknown here, or 3 equation from the matrix. After that, you rewrite the remaining equation after you close the equation with the boundary condition. Then you have M2. M2 here, because it's free to rotate, there's no moment at point 2. Capital M here, capital M 0. And point 3, you have an external force, F3y, capital F is the external force. So you have a negative P going down. M3, 0, because M3, there's no rotation here. Right? There's no rotation here. Then you are having 3 equation here. P, there's a finite value here, is a negative 50 kilonewton. So when you calculate, remember to carry the K here. So in your calculation, remember to write the full number, yeah, 50,000 in here. All right, for your test, just a reminder, for your test, you need to calculate up to 3 decimal place, minimum 2 decimal place. But it's good that you get up to 3 decimal place. Yeah. All right, then you try to solve. You will get your V3 equal to something in the term of PLEI and K, because K is a complex. K is this one. K is KL cubed divided EI. Yeah. So you write something here. You write in a formula. You get the rotation number 2 equal to this one. Then you get rotation 3 equal to this one. Yeah. So go later. You can come back to this one for the detail. On this slide, I just show you that you can get answer after you solve simultaneous equation. You can use inverse for your test or exam. If you're not good in inverse matrix, you're not comfortable, you can use simultaneous equation to solve the answer. Meaning you build 3 equation and then you solve 3 equation using simultaneous equation. Means equation 1 substitute into equation 2, and then you take another 2 equation to minus or plus to cancel out, and then you substitute back. Then you'll get the answer. All right. So if you're not sure how to do simultaneous equation, again, go back to the calculus or advanced mathematics textbook. Go and study about how to solve 2 equation or 3 equation, simultaneous equation, or even 4 equation. Yeah. So if you have 4 unknown, 4 equation, you can solve. Yeah. All right. So if you put in the answer, you'll get something right what you see on the screen here. So V3, you will get negative 0.0174 meter. Rotation is in the unit of radian. So it's not degree, yeah? It's in the unit of radian. So you have negative 0.002 radian. Rotation 3 will be negative 0.007 radian. And then in your test or exam, most of the time you'll ask you to explain what mean by negative. Right, what mean by negative? Or we will ask you to sketch the direction of that particular displacement, either rotation or vertical displacement. So if you look at the answer on the screen here, right? So we have three answer there. I'm going to ask 3 of you. Singi, what is the direction of V3? Vertical displacement?
Going down.
Going down. Because?
Because it's negative.
All right. Good. Excellent. Katana, the next one will be for you. Rotation number 2, we get negative. So what is the direction?
Clockwise.
Clockwise, correct. Lai, rotation number 3, you get negative. What is the direction?
One.
Okay, clockwise. Right. Lai, you need to improve your connectivity over there. Your connection is not very well there. All right. So seems that most of you able to capture what we need to cover today. So after that, you solve F equal to KD because you already have all the displacement value over here. The D you already have already. So you have all the complete set of equation on the right hand side. So basically you have 7 equation on the right hand side. If you build so F1 equal to 12 V1 plus 6L rotation 1 and so on. So you have 6 equation there you can solve. So I just give you the answer. F1y equal to this one, F2y this one, and so on. Right? I'm not going to go deep into that. So once you solve the equation from this matrix, you'll get answer similar to this page. This is just a checkpoint for you so that you know that you are in the correct direction. Important is that you understand the concept. And then, one thing that we will test you or evaluate you in exam is you need to draw free body diagram. Same with the coming test, either next week or another 2 weeks. You need to know from the calculation, you need to know how to draw a free body diagram for that particular element or for the whole system. So I show you the body diagram, free body diagram for the system. We just convert the system, the beam system, into all the answer that we calculate. So we are focused on point 1, point 2, point 3, and then you transfer all the answer that you calculate from the matrix itself. So for example, F1y, you get negative 69 or negative 70 kilonewton. So you draw down arrow, negative. Point 2, you get 50, go down, and then there is a 3.5 here, right? F4y, which is from point number 4 here. Yeah, point number 4 is going up, so you get 35 positive going up. Yeah. All right. So you need to know how to draw free body diagram. Okay. Any question for this example? Okay, you guys can go for you guys can continue for one more example. Can we go for one more example without break? Then we call it a day.
Okay, sir.
Can. All right, Singi, can you continue?
Yes.
All right, Lai, you all right?
Yes.
All right, we continue. So we look at tutorial question number 9. So this one is much simpler system. As you can see on the screen here, you're having point 1, point 2, point 3, and actually it's a single beam with one focus load on the center, 10 kilonewton at the center of point 2, and there is a anti-clockwise moment, external moment at point number 2, which is 20 kilonewton meter. In this case, you need to find displacement and rotation of the beam. Yeah. So same SOP, same procedure. You are given the E and I, and you solve what is happening on this beam. All right, now I'll just show you the answer. So element 1, you write the stiffness matrix again. Same, but you need to know what is the meaning for all these number here. The first 2 column is referring to point 1. The later 2 column referring to point 2. What I write over here, the black mark here. Again, when it comes to test or exam, the black marking, we recommend you to use pencil, or you can use other color pen. Don't mix the answer here. Yeah. Element 2 will be the same number, but again, it represent different meaning for the matrix over here. So element 2 connecting point 2 and point 3, so you'll get point 2 and point 3 value. First step, you write element matrix. Second step, you just combine the matrix together. you'll get something like what you see on the screen here. Again, in test or exam, you need to write the empty portion here. It's a symmetry number that you get on the top diagonal here. All right. So you combine the matrix into stiffness matrix. Remember to take note on the notation you use. If you represent element, use small k. If you look at global matrix, you use capital K. All right. Then after that, we move on. So just to help you to self-check, you can write the notation above the matrix. First two column is 0.1, middle two column is 0.2, the last two column is for the 0.3. Okay, I highlight for you with the bracket over here. So the green box here is for element 1, and another pink color box here is for element 2. So after that, you write F equal to KD. F equal to KD. For beam, again for the beam, on the left hand side, you have force and moment. And remember, you already arrived at the global scale or global matrix. So use capital F and M for left hand side. And then for displacement, you have the vertical and rotation for beam. So then you solve according to the boundary condition. Again, I think you already understand. If you look at 0.1, you don't have rotation, you don't have vertical displacement. 0.3 also same. You don't have vertical displacement. You also don't have rotation. 0.3. All right. Stop me if you're not able to understand what is you see on the screen. All right. You don't have vertical displacement, so you just close it. We are not cancelling, but you just close it. Same with rotation 1. You close it. Then vertical 3. Also you close it. And then rotation 3, you close it. So by closing all these boundary condition, you know that you only arrive at a very simple matrix. Will give you 2 times 2 matrix. It is you need to find out what is F2y M, and then you use back the EIL and then bracket the 4 value over here and then the 2 displacement. Okay. You arrive at a very simple equation over here. F2y you replace with a number, and remember when you replace number, be careful on the direction. Your 10 kilonewton in this case is going down, so when you substitute into the matrix here, remember to put a negative. Yeah, so this positive negative notation is the most area that students make mistake when it comes to tests. So be careful on the notation. Don't just copy the magnitude and then forget about the direction. Negative in this case going down. M2 in this case is anti-clockwise. So anti-clockwise is positive in this chapter for moment. So you carry the positive, and then the rest is just substitution of the number. And this is a 2 unknown that you need to find. So after that, you substitute, and then you do the calculation. You have 2 equations to solve. After you solve, you get the 2 unknown here. So I'll just give you the answer. You can find what is the vertical displacement at 0.2, what is the rotation angle at 0.2. Just to highlight, the unit for vertical displacement will be in meter. Rotation will be in radian. Don't write degree, it's a radian. Radian. Okay. We need to determine displacement for other. So we only solve the 2. So we need to put in everything that we know. So we focus on individual element. We take what we have for the global dimension, capital F. When you look at individual element, then remember to chain it to small f and small m. And you just copy all the displacement that you know. And be careful when you copy into individual element, you need to focus on the row and column value when you copy down. So just to remind yourself, there is a combination of number here. So when you copy, don't copy the total number here. For example, for element 1, you only consider 12, 6L, 6L, and 4L here. So don't plus 12 when you do the element 1, yeah? Because element 1, you only have 12, 6L, 6L, 4L square here. So that's why when you calculate this one, there is no another plus 2L. There's no, just be careful. All these are the mistake area that student will make mistakes. Be careful when you transfer data from the previous steps. Yeah. All right. Lai, you understand why this one is 12 and not 24? Lai, do you understand?
Yes.
Okay.
Yes.
Okay, Katana, you understand why this one is 12 and not 24? Katana, are you there? You understand?
Yes. Yes.
Okay, good. Right. Then the rest is just put the answer over here. You can find the value of, because this one is 0. So you're able to find what is your F1y and your M in this equation. So I write in a purple color on the right hand side of the screen here. And then you can find another 2, F2y here. So basically you're solving 4 simultaneous equation from element 1 matrix here. Yeah. All right. Then you solve for element 2, do the same, repeat the same. All right, repeat the same. Just copy from the global matrix there. Again, be careful not to copy the wrong one. So for element 2, you're looking at this number. Remember, there's a positive negative sign there, so don't copy the wrong one. Repeat the same. You're solving 4 simultaneous equation. Then you'll get all this number. Okay. Then after that, you put all the answer one side. You need to draw a free body diagram for the answer. So this is how you draw it. So for element 1, you have 0.1 and 0.2. So just put in all the answer. F1y is positive, is going up. F2y negative, going down. Moment at 0.1 is positive, so it's anti-clockwise. 0.2 is positive, is anti-clockwise, and then you put in the number here. This is for element 1. Element 2, you look at the answer over here. So you have 0 forces in the element. So you just put 0 and then put arrow there, right? So the arrow, how you know the arrow is actually come from the previous, his neighbor, where if you look at element 1, is going down. So there will be a counter direction. It will be going up to counter the force over here. So you draw up, although it's 0, but the direction we assume that it will be a come by coupled effect where it will be opposite direction of the neighbor, this one. So the next one, although is for 0.3, although is 0, the direction is also coupled to balance the beam. So one go up, one will go down. Then the next one, we look at the number that you calculate, positive value for 0.2. For element 2, you get 2500 positive, so it's anti-clockwise. M3, 0.3 negative value, so it's a clockwise. You need to know how to draw a free body diagram from the answer. You will carry some marks for this one. Then after that, you need to know how to convert into shear diagram. So shear diagram is vertical shear loading. Is a shear loading versus length. So shear diagram for element 1, you will start with positive because it's going up, positive 10 kilonewton all the way until then out all the way until the end. Then there's a negative sign going down, so your force going down, your shear loading going down, or shear force going down. Same with the element 2, because there's no loading, F equal to 0 in the diagram. So you just draw the axis, V versus length, and you put 0 over there. This is for shear diagram. Second one, bending moment. So bending moment, you have a negative 1250 because this is a clockwise. So clockwise is a negative. So we start with negative 12.50 and then you end at a positive 17.5 Newton here, right? So let me check. All right. Then the same for diagram number 2. Okay, next lecture we'll look at distributed load. Let me stop the recording.